All right, here we go. So let's go into the review. So just to be clear, you should have already tried all the problems, and this is used for checking. You can watch it as fast or slow as possible, whatever helps you be able to do these problems on your own, because you need to do these problems on your own for the test, right? Okay, so there's the definitions there. You can pause it and read it if you want to. Add or subtract for arithmetic and multiply for geometric. Even if you're dividing, that still can be expressed as multiplying by a fraction. So keep that in mind. Okay, so we're looking, is this arithmetic, geometric, or neither? And what's the common difference or ratio if we see it? 3 to 12, what's 12 divided by 3? It's 4. 48 divided by 12 is also 4. So we are geometric here, and which gives us a common ratio. We're multiplying by 4 every time. 4 times 48 is 192, times 4 is 768. Right here, if you did 106 divided by 16, you get 6.625. And then if you do 1006 divided by 106, you get 9.49. These are not the same. Therefore, it is neither. I should say that means it's not uh, geometric. And I could see that uh, that I'm not adding the same every time. To get from 16 to 106 is adding 90. If I added 90 again, I wouldn't be at 1006. So it's not arithmetic. It's not geometric. It's neither. Okay, right here, we need to write it. The thing that most people struggled with most is writing the formula. A lot of people are doing a good job using the formula, but writing the formula, we're kind of struggling a little bit. So just to be clear here, to write the formula, we'll need the first term. Okay, we've got negative 13 in this case. What's happening here? I am adding by 6. If I wasn't sure of that, I could have done 5 minus negative 1, or think about how far negative 1 is from 5. And it is a common difference of positive 6 and negative 13 to negative 7. That is positive 6 as well. So my formula, that is a of n equals my difference, which is 6 times n minus 1. And then I need to add, or in this case, subtract my first term. Now, I need to find the 42nd term. This is a perfect example of maybe you don't need the formula when it's smaller numbers, but to do this 42 times, that could get pretty old. So to find the 42nd term, I need to take that difference, multiply it by 41. That's n minus 1, and then take 13 away from that amount, which gave me 246 minus 13, and my 42nd term was 233. I'm going fast because my assumption is you've already tried this, and I've already tried it. I have it in front of me as I'm going. So make sure you're putting these things in the calculator, not just writing this down. If you can write down what I wrote down, that's not really going to help you on your test. What's going to help you is being able to actually do these things. They're arithmetic again, so I know that we're going to add or subtract. In this case, our first term is 34. Our common difference, we're going down, so we're subtracting by 10. Okay, so a of n equals my difference times n minus 1 plus my first term. To find the 30th term in this case, I'll need to, I'm not sure why I wrote my 0 like that. I'll need to take negative 10, multiply it by 30 minus 1, which is 29. Add 34 to that. So I get negative 290 plus 34. end up with my 30th term being worth negative 256. Okay, now it's geometric, so I know I'm going to have to, yes, find the first term, but now I have to find a common ratio. I find that ratio by doing, in this case, negative 16 divided by 8 gives me negative 2. My first term is 8, so I need to take that first term for the formula and have it out in front. That gets multiplied by my rate, which is negative 2. And I need to go to the power of that term minus 1. So to find the 10th term, I'll need to take 10 and take 1 away from it, which would be 9. Multiply all that, and that gives me my 10th term of negative 4,096. Switch it up. Let's go green. Ooh, can't believe I said that. It's okay. I'm not as hardcore Michigan fan as I used to be. First term, 6,561. My ratio, got to do a little work for this one. 2,187 divided by, this is a perfect example. You can't really tell by what's going on here. So you got to actually use these steps, which gives me 0.33 recurring, or 1/3. Okay, so we would need to take, I'm just noticing that on my table, I didn't write this and I don't have my calculator in front of me. Let's see if we can do it without. I don't know, that power I'm not going to be able to do. All right, so my term here will be the first term, 6,561. And my rate was, if you left it as 0.33 recurring, that'd probably get away with it, to the power of n minus 1. Get my 10th term. After you do this one, because you guys will have your calculators when you're doing it, bring it up to me and show me. Take that to the power of 9 and get it. I don't have my calculator on me, so I can't do that one. Maybe I'll find a calculator in here when we're done if I have time. Okay. Onward. All right, what type of sequence we looking at here? If you look at these dots, we're curving upwards at an exponential rate. So this is geometric. How do I know? Because that line is creating exponential growth. You guys can't tell, but my head's in the way there, from my view anyway. If we connected these dots, it'd be a straight line. Therefore, it's arithmetic. I can tell it's arithmetic because it's linear. Right here, you'll see my lines are all over the place. So this is neither y. There's a lot of different ways to say it, but I think the one I landed on, at least for the key, will be that this is inconsistent growth. Inconsistent, just like I spell that inconsistently sometimes. Okay, I kind of had in my key, I did this a little sloppily. So let me make a neater version of this table. So if I were going to do I would do a table for this. And I would say, okay, if this is the first term, right? If this is term 1, this is term 2, this is term 3. How many dots do I have in each of these? The first one, I have 2 dots, right? 1, 2. Second one, I have 4 dots. 1, 2, 3, 4. Third term, 1, 2, 3, 4, 5, 6, 7, 8. All right, so I like tables. They help organize things for me. I see here that I'm going 2 times 2 is 4, 4 times 2 is 8. So describe how the number of dot increases from stage 1 to stage 3. So start with 2 dots. Multiply by 2 every time, aka doubling, right? It's the geometric or arithmetic or neither. Well, like we said, we're multiplying by the same thing every time. So it's geometric. Why? Because we're multiplying. Definition for sequence D. Okay, so again, we would say with the dots here, just to give our general formula here, we would have our dots as a function of n, right? We've got our first term. So our first term is 2. Our rate was 2. We would need to go to the power of n minus 1. All right, so I kind of had to arrange these questions a little differently because it wouldn't have fit all on one slide, and I wanted to make sure everybody could see every step of the way. So I'm over here on the right for part A. That says for sequence A, describe a way to produce each new term from the previous term. Okay, so first I would have to say, hey, my first term is 2. Oh, we're talking about sequence A. Sorry, let me clear that. Sequence A. All right, so my first term is actually 1/4. All right, first term is 1/4. And then what's happening after that? 1/4 to 1/2 to 1 to 2 to 4. Maybe it's not obvious until you get here to the 1, 2, 4s, but we're multiplying by 2 every time. So first term 1/4, or you could say start at 1/4. And then last time I said multiply by 2, so how about I put double every time? All right, sequence B. How about let's make sequence B blue. Describe a way to produce each new term from the previous term. Now I'll circle 2. Say, instead of first term, I'll just say start at. Either way works. Start at 2. I go from 2. I'm looking at the y values here. Oh, just realizing that our first term, so you'll have to double check your keys here. This went over to the 0 term. We'll come back to this. So we'll actually say that this is the first term for the purposes of what we've been doing. Okay, so we'll say start at 12 because it's the term of 1. And then regardless, we're going to add. So if you looked at the printed key that I posted, there's going to be a little discrepancy there. Maybe I'll rescan it. We want to start at 12 and add 10 every time. All right, so sequence A, we've got a first term of 1/4. So how would I write that? The definition rule would be if n equals 1/4. Our rate was 2. We doubled, so we need to have 2. We need to go to the power, term number 0. All right, so again, and I screwed up earlier. Probably wouldn't be that picky on the test, but either way. We started, actually, our first term was 1/2, so we could change this up here, first term to 1/2. So I did on both of them, but so my first term here is going to be 1/2. We're still doubling. We're going to the power of n minus 1. Okay, now is there a way to use the zero term? Yes, you've learned it with y equals mx plus b in the past, but for the purposes of what we've been learning, let's stick to our first term. Let's look at sequence b. Again, we'll say starting at 12, so the nth term is equal to our difference, which is 10 times n minus 1, and you're going to add 12. And I'll have to double check my key now because I used the wrong first terms before. So I'll have to do this math again. All right, so let's check A of 9. So here's sequence A and sequence A. So right here it's asking which is greater, A9 or B9. Um, this is like right on the edge. Do you want to keep doing this all the way up to 9 times? I would say that the rule is probably the better way to go. So let's look at the ninth term here. If we do the ninth term, we're going to need to do 1/2 times 2 to the 8th power. Okay. See, now I got to do some quick math here. 2 to the 8th power, 2 times 2 times 4. I think it is 128. Double check. I don't want to be wrong again. All right. And this one also not working. Let me double check. Pause for complications. Not great. I think actually it's 356. Let's double check. Got to go back and fix that other one anyway. All right, so 2 to the power of 8 gives us 256. Multiply that by 1/2. And that gives us 128. Yeah, so if you looked at the printed key, right, I was working with the wrong rule, so double check here. I'm glad we're doing this. All right, so the ninth term for A9 ended up being 128. And then for the ninth term here, we need to, this is a little easier, multiplying by 10. Nice. I should have wrote B of n. So the 10th term for function B was 10. We're doing the 10th term, so we're going to multiply that by 9 and then add 12. So 90 plus 12, 102. So in this case, we have just proven that A9 is greater. All right, and since we've already busted the calculator out, let's go back to the one where I wanted to use a calculator. Have it, where was it? There we go. All right, 6,566. So if you flip back to number 4 from previously, and of course, every time I do that, I forget what number I just said. 6561. 6, 5. It's getting clunky at the end. It ran pretty smooth there for a bit. They'll get better, I promise. We got 1/3. We're going to go to the power of, what was it? 9. All right, so if you're still around, check that last problem. And the answer ends up being one that it's no fun anyway. It ends up being 1/3. So what a way to end it. Okay, so despite this clunky end, hopefully you're able to use this key to help you. So your final answer here ended up being 1/3. All right, check with me in class if there's questions on these. You guys are going to do great. Let's see if I can end the share. Stop the recording. All right, see you everybody. Good luck on the test.